Team 3, Investigative Case Study. The United Nations Sustainable Development Goals, UN SDGs, are a total of 17 goals with 169 targets that all UN member states aim to achieve by the year 2030. The UN SDGs are a set of goals that are designed to realize the vision of a world free from poverty, hunger, and disease. These goals are relevant to every country and every individual, regardless of socioeconomic status. They aim to promote prosperity whilst addressing the environment and improving equity to meet the needs of women and children. Swinburne University has been involved in an initiative called the India Project since December 2014. The India Project is based in remote tribal India, in the village of Pal and its surrounding villages, Muhammad Ali, Jamnia, and Mangrove. Through collaboration with various partners, the India Project facilitates improvements that align with the UN SDGs and also addresses the impact of previous iterations to deliver recommendations for future iterations. My name is Jarvis, and with me today are Brad, Roncey, and Harry. In our investigative case study, we will explore a significant issue within the agricultural sector in rural India and propose a viable social technical solution that is feasible, facilitated by the concept of Imagineering. We have adopted a unique approach, building on existing resources and leveraging simple technologies in our modern world that specifically addresses SDG 15, Life on Land, and its targets. Over to you, Brad.
Thanks, Jarvis. My name is Brad. As just mentioned, we have chosen SDG 15, Life on Land, as our topic for discussion and investigation towards leveraging technology in power. SDG 15 is the United Nations goal towards sustainability relating to life on land. Taken directly from the United Nations, the goal is to protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forests, combat desertification, and halt and reverse land degradation and halt biodiversity loss. Globally, forest areas are declining due to agricultural expansion, leading to the destruction of 10 million hectares of forest. Additionally, 2 billion hectares of land are degraded, affecting 3.2 billion people and threatening 31,000 species with extinction. For the team to address this challenge, we assessed SDG 15 in line with India and more specifically PAL, therefore ensuring the solution is specific to their local agricultural challenges. As a global leader in farming and agriculture, 44% of India's population are farmers. Additionally, India's share of crops is 60%, compared to a global average of 11%. With such emphasis and importance on farming in India, additional steps should be taken towards achieving SDG 15. Within SDG 15, there are 12 targets which need to be met in order for the goal to be achieved. We use these targets to narrow our investigation and ensure that the solution is positively contributing towards life on land. In particular, Target 15.3 aims to restore degraded land and soil, including land affected by desertification, drought, and floods, and strives to achieve a land degradation neutral world. In addition to India's large share of crops and population of farmers, it is important to note that 52% of India's agricultural land is unirrigated and rain-fed. In relation to Target 15.4, a key contributor to land and soil degradation through rain-fed agriculture is increased wetness and poor drainage. Therefore, leading our investigation towards a solution which better communicates weather and rainfall to farmers in the PAL region. Now on to Roncey, who will dive deeper into the background and research approach.
Thanks, Brad. I'm Roncey. As Jarvis mentioned earlier, the India project takes place in the rural village of Pal, which is in the Jalgaon district of Maharashtra. Pal experiences diverse weather conditions, including a high level of rainfall in the summer and monsoon, and little rainfall in the winter. Weather forecasting in farming is incredibly important. Whilst there are 16 weather stations in the Jalgaon district, the nearest one to Pal is located more than 35 kilometres away. Publicly available data is not accurate enough for farmers in Pal to make informed decisions, to make the best use of the land and to manage the risks. Given that more than 70% of rural families in India depend on agriculture for their livelihood, this is very important data. Accurate and localized weather data will help local farms improve the sustainable use of the land. It will help them to plan where to put water stores or which areas will benefit from irrigation, and can guide decisions about what and when to plant, when to harvest, and when to apply fertilizers and herbicides. Improving the production of the land supports the goal of sustainability, as higher yields will mean less need to cut down more forest, in turn protecting biodiversity and reducing land degradation. Our team approached this with a 7-step process that had a mix of individual and teamwork. First up, we gathered information about the India project and the SDGs. We narrowed our choice to 2 SDGs that we wanted to work on, either gender equality or life on land. We went away individually, brainstormed and ideated, then brought that to a group session where we decided on our focus, SDG 15, life on land. Further individual research took place into our focus area, then another group session for the problem solution ideation, including fleshing out the feasibility and limitation issues. We then honed and iterated our solution as more information came to light.
Our proposed solution is a mobile application which will be integrated with weather stations to provide users with a range of tools to help improve farming efficiency. The weather data will initially come from existing weather stations that have been installed in the surrounding areas, and additional weather station nodes can be added to increase data accuracy. This will also expand the area in which the application can be successfully used. The weather station nodes will feed data into the mobile application, which in turn will provide basic analysis, which can recommend crops for the microclimate, provide historical data which will assist in future agriculture development decisions, and send custom notifications based on user set flags. The application will be designed with expansion in mind to allow for more advanced data analysis and predictions in the future. The mobile application will aid users in choosing crops which can be the most efficiently grown within their own microclimate. The application will choose the closest node's weather data and compare it to various crop requirements in order to determine what crops are most suited to the area. This will work to increase efficiency of production as well as minimising wasted growing seasons due to subprime crop allocations. The application could also be expanded to have the capability to send notifications to users for various reasons. For instance, users could opt in to a heavy rainfall notification, which would alert them to severe rainstorms and allow them to make decisions preemptively. Weather stations are currently in the surrounding areas, and additional weather stations can be purchased for relatively affordable prices. This will expand the weather station node network. One of the biggest limitations is that the area suffers from variable phone coverage. Weather stations will need to be placed in areas where they have constant coverage, as they will need to frequently update the clients. This will potentially cause problems for some areas, as they may not be able to access a weather station close enough to provide accurate data for their current microclimate. The poor coverage will also affect the mobile application. However, a caching mechanism can be developed so that data can be downloaded when in reception and stored on the device. Another hurdle for the project will be training. It's one thing to provide data and another for farmers to apply it to their farm. Video training could explain the basic application. However, site visits may be required in order to teach farmers how to apply this data to their own farming strategies. Finally, it will take several seasons for there to be enough historical data to make predictions that could cater to many of the regions and their microclimates. This is why it is important to start recording the weather data as soon as possible, and in the future the application can be expanded to make the most of it.